Well, yes, friends, in this video, I'm going to discuss about radioactivity. In last video, I told you what is radioactivity. That heavy nucleus means the nuclei of heavy element are unstable. To achieve stable structure, they release some radiation which are called radioactive radiations, and those radiations are found to be of three types: alpha, beta and gamma. So here I will tell something about the three decays. So first of all I take here alpha decay. I told you that alpha particle was found to be helium nucleus 2He4. So during alpha decay, the mass number of the nucleus decreased by 4, atom number by 2, and during alpha decay the mass number of daughter nucleus. Daughter means product nucleus after decay जो बनेगा product nucleus, daughter nucleus is found decreased by 4, decreases by 4, and atomic number by 2. That is, if it is ZXA is the parent nucleus, this is called parent nucleus. It decay into 2He4, that is alpha particle. Then daughter nucleus will be Z minus 2. It will be certainly other element because atom number is the number of protons present in nucleus, and that determines the name of element, or A minus 4 plus Q. Q is the energy released. By applying law of conservation energy momentum, it is found only here that the energy will release if mass, sum of the mass of alpha particle and daughter nucleus is less than the mass of parent nucleus. Then according to Einstein equation, energy E equal to, है ना, जो energy होगी limited Q, that is equal to m ZXA plus m 2He4 और प्लस नहीं माइनस mass of Z minus 2 by A minus 4 C square. So it will be the energy released. This energy can be calculated, and again by applying law of energy, actually daughter nucleus is much heavier than alpha particle. So majority of energy is shared or is taken by alpha particle, and kinetic energy here of 2He4 has been proved. A upon, sorry, A minus 4 upon A into Q. And here all alpha particles were found to be of same kinetic energy. The alpha particles, I told you, 83 B bismuth, 209. The kinetic energy of particle was found to be 5.5 MeV. So here the most famous or most general decay of alpha particle is of uranium-238. Uranium-292, uranium-238 decay into 2He4 plus 90 thorium 234 plus Q. So this is the decay scheme for alpha particles. Now alpha particles takes place from heavy, are emitted by heavy nucleus like thorium, this bismuth. Now this thorium may further be stable or unstable, that is another thing. उसकी बात हम बाद में करेंगे. But you are requested to learn the mass number and atom number of some heavy elements like like uranium, thorium, plutonium, रेडियम एक्सेट्रा और बहुत सारे एलिमेंट हैं. नाउ आई कम टू बीटा डीके. Small knowledge is required here. Beta decay. Radioactivity is the nuclear phenomena. I have told you that for radioactivity, nucleus is responsible. Nothing to do with the electrons present in outermost in the different cells or orbitals. उनका कोई लेना देना यहाँ नहीं है. Radioactivity it is totally nuclear phenomena. So during beta decay, actually, initially it was found that during beta decay, an electron is emitted. Therefore, emitted according to equation. Zxa is equal to -1 E0. I write like this. -1 is the atom number. It means इसका charge negative. But our NCERT will write like this. Plus Z plus 1 Ya. Mass number does not change. Atom number of the total nucleus more than 1. Plus energy Q. This was the initial thought that the beta decay take place like this. And just I told you that in alpha decay, all alpha particles supposed to have same kind energy. When energy of electrons, beta particle, were measured, here kinetic energy of beta particles, means electrons, were found to be varying from 0 to certain maximum value. Certain maximum value. Means we can say here that spectrum of kinetic energy of beta particles was continuous, and hence we can say spectrum means value present in the ray continuous. Spectrum of kinetic energy of beta particle was found to be continuously, to be a continuous spectrum, to be a continuous spectrum, like this. Here kinetic energy in MeV, and here number of beta particle M. So 0.5 MeV, 1 MeV, 1.5 MeV, like this. So that spectrum came like this. Means in this range, electron of all possible values were found. Then why this? Actually, I am telling this. Once there was question in board, in our NCRT book, they have eliminated this thing. They are writing directly what I will be telling you now. So why this? Why the electrons emitted should have same value of energy, but not like this. But it was found practically like this. So why it is so? So to explain this, people could not understand, but theoretically Pauli proved that during beta decay, one more chargeless and very light particle is also emitted, and this particle is called neutrino. Sorry, antineutrino. This is called antineutrino. So the equation is like that. Zxa is equal to -1 E0 or beta -1 plus Z plus 1 XA or YA plus antineutrino plus Q. This energy Q is shared between all these three: beta particle and daughter nucleus and antineutrino, and that is why this spectrum is continuous. This question had been asked last back in board exam. Why the spectrum of kinetic energy of beta particle is continuous? Now, how it takes place, from where electrons have come? But electrons are not present inside nucleus. Then from where they have come? Actually, when neutron proton ratio become more than 1, a neutron may decay into a proton plus electron plus antineutrino. Electron cannot remain inside the nucleus, so come out. Proton remain inside, that is why atom number get increased. Already here Z plus 1. The sum of number remains same. So it is the region of beta decay. Neutron inside nucleus decay into proton, electron, and this example of this is 15p32. 15p32 phosphorus. It gives -1 E0 plus 16s32 plus antineutrino. One more 6c14. 6c14 carbon. This is the isotope carbon radioactive. Radioactive isotope. एक बार ये वीडियो बाद भी मैं radioactive isotope, the isotope of elements with so radioactivity are called. So it also decay into -1 E0 plus 7n14 plus antineutrino. Many cobalt 60 also decay into 27 CO60 decay into -1 E0 plus 28 Ni nickel 60 plus antineutrino. These neutrinos are very light and chargeless but have high energy, so they can penetrate through material and they remain undetected for a long time. Antineutrino, being chargeless and very light and having large amount of energy, remain undetected. Now, practically it has been found that along with negative beta decay, there is positive beta decay also. Positive beta decay is also possible. What is that? ZXA is equal to plus 1 E0 plus Z minus 1 YA or plus neutrino. This is neutrino here. Neutrino, antineutrino are particles having no charge, but they are called anti of each other. For example, for this is, इसके लिए एग्जाम्पल दिया है इन्होंने 11Na22 11Na sodium. Yesterday some student came to me. Actually we run one hostel, so in hostel the admission is done by me. So I asked them 12th class pass, getting 65 marks in chemistry. I asked formula of sodium nitrate. They were not known as SONO3. SONO3. SaNO3. SONO3. सोडियम नाइट्रेट. नई केमिस्ट्री चली. बेटा पढ़ लो, मान जाओ मेरी बात. पढ़ने से गुजारा होगा. Student who have passed 12th class don't know what is sodium nitrate. I have noticed this thing heavily happening here. So beta decay plus 1 E0 plus 10 any neon or plus antineutrino. So this way positive beta decay is also one of the activities shown during, and this has been verified practically in cosmic ray shower. Now you may ask me what is cosmic ray shower. Cosmos, अंतरिक्ष हिंदी में कहते हैं, the space beyond solar system. Our universe is made up of galaxies. There are 10 to power 11 galaxies. I think हो सकता है कि आप जानते हो इतनी गैलेक्सी हैं, इतनी गैलेक्सी, and one galaxy consists nearly 10 to power 11 stars. Some galaxies are normal, some are radioactive. So beyond from solar system we are getting some radiations which are called cosmic rays. These cosmic rays are initially, before they enter our atmosphere, they consist of 89% proton. 89% proton हैं, and rest are heavier nuclei. Heavier nuclei. 89% proton and rest are heavy nuclei. When they enter atmosphere, they collide with the nuclei of elements in the atmosphere and make them to break. And secondly, cosmic rays are there. In those cosmic rays, there are nearly 100 particles. बहुत सारे fundamental particles हैं. प्रोटॉन, न्यूट्रॉन, इलेक्ट्रॉन आर नॉट फंडामेंटल पार्टिकल, बहुत सारे यहाँ पे. तो उसमें वेरीफाई किया पोजिट्रॉन, इलेक्ट्रॉन आर प्रेजेंट प्रैक्टिकली. नाउ इन नेक्स्ट वीडियो आई विल बी टेलिंग यू गामा डिके, स्कीम ऑफ गामा डिके, क्योंकि लंबा हो जाएगा इसको.